All right. For those of you who have joined us, thank you for being here. We greatly appreciate it. We've got a good one for you today. Joining us is Scott Hanton, editorial director at Lab Manager, and somebody that Yahara's collaborated pretty closely with. We're excited to get his view on some of the AI at the bench hype that's going on right at the moment. For those of you joining us, we'd love to hear from you as we start this discussion. It's going to be pretty open format, and we're just going to be talking. We'll keep our patter rolling, but if you've got comments for us, drop them in the chat. We'd love to hear from you, and we'll leave a couple of minutes for any extra questions at the end, but we're happy to take them all the way through. For those who've not joined us before, my name is James Smagala. I'm the Bioinformatics Practice Manager at Yahara, and we've also got Adam Steinert, our Chief Technology Officer. Thank you all for joining us, and I'd love to just sort of kick off. And when we were discussing what we were going to be doing in this, Scott, you shared a great story with us. The three lab managers and the big bad AI, which has the advantage of being true. Maybe would you sort of start us with that anecdote and let's use that to open up the conversation a little bit here.
Thank you, James. I'm happy to share that story. So I was recently at a conference and there was a panel discussion where there were three senior experienced lab managers on the panel. And one person in the audience asked them sort of an open-ended question of, what do you think of this AI technology and what are you doing with it? And the three answers really couldn't have been more different. The first lab manager to speak up was pretty clear. She works in digital pathology. Her response is, I've been using AI and ML technology my entire career. And in this field, we've been using this kind of science for at least 30 years. It is routine, normal, every day. Yes, it's getting faster and it's getting better, and that's to be celebrated. And just can't wait for the next innovation in the technology. And then the next person went, and his response was AI hallucinates, AI makes mistakes, can't find a place for it in my lab. I'm afraid of all the errors, and we aren't using it today, and sort of over my dead body sort of response. And then the third lab manager had a response that was, hey, I hear the hype. I can seen some examples, but in my lab, I just can't figure out how to use it. I'd like to use it, but I don't know how, and I'm a little scared of making a big mistake. So we heard from, it was only a group of three people, but we heard sort of three completely different answers on this topic. And these are all experienced people with long track records of success. And the room was full in order to hear their response on a variety of things. But this question brought a very diverse answer from the panel.
I think it's a beautiful starting place because every one of those has the advantage of being true and valid and a lived experience. They that really is the breadth of sort of where you could be with AI, and we're seeing all of it. So I think that's sort of the perfect place to open up a little bit. I'd like to unpack each of those. And let's start with sort of the of course we use AI answer. And it's an interesting one to me because when we say, well, I've had it for 30 years, we're not talking about the generative AI revolution of the last 2 or 3 years. We're talking about machine learning applied to image recognition or a number of other sort of tasks that have already been reasonably well defined. And that really was cutting edge technology even only a few years ago and is still the foundation for a lot of sort of the modern use of these systems in ways that is directly helpful to the laboratory. Adam, give us a little bit of a view of where you can go with some of the machine learning side of this.
Yeah, certainly. I mean, that doesn't get a lot of play lately, right? I mean, everybody's talking LLMs and what we can do with, ChatGPT, but the traditional, machine learning approaches, have been around for decades, and as Scott, noted in your examples, in use for a long time, doing important work. Um, and while they get uh, perhaps overrun by the ongoing discussion of sort of the new interesting tech, um, there are places where we've seen broad adoption of those practices, and places where we haven't. And collectively, we've certainly talked about some of the issues there, and I think why it may not be as widely adopted as it could be. Um, and really that drives us to the conversation of the data that backs those types of usages. Machine learning algorithms that traditional type rely on data. They're coming up with their results by looking at existing data that's provided to them to predict a categorization or some type of result. And I think what we've been seeing in the industry right now is perhaps people that don't have some of the more specific use cases that are very tailored to those approaches. They haven't yet understood how to prepare the data that they need in the way that they need it to make those approaches helpful to them in their day-to-day lives.
And then, Scott, I think I want to take your other two lab managers sort of as an interesting compare and contrast here. And that is the absolutely not in my laboratory, it hallucinates and you can't trust it, versus I know I'm missing out on something. I'm scared I'm not on the leading edge of this, and I'm not going to get full advantage of that technology. Those are both valid fears and in direct opposition to each other. How do we start to reconcile that?
I think there's a real education component myself. And I think, James, that you nailed it when you said that they're driven by fear. And one person's fear of missing out, and the other one's is fear of being harmed. But they're both fear driven. And I think the best thing we all can do, or maybe I should say you all can do, is to provide the kind of education that people can then make decisions from knowledge rather than the emotional, raw response to fear and the unknown.
And I think that's a really good framing for this. And Andrea, you've played directly into our hands here. I'm just going to read out Andrea's comment for everybody. I'm hesitant about using AI due to wanting to keep the balance of efficiency and protecting the company IT policies. What are your recommendations? We've got some fairly specific ones, but I hear that hesitancy and I want to acknowledge that. It's that's a healthy fear, right? I don't want to tell you never be afraid, and in particular, staying in line with company IT policies and making sure that you are not just broadcasting sensitive data out to the broader world. That is a healthy hesitancy or fear, or call it what you will. Please keep that and never let go of that. You do want to do this the right way, and that's part of sort of that education that Scott's talking about, is nailing down how that's going to go. We can provide maybe some specific thoughts about really making sure that you have an enterprise usage agreement in place and understanding what data can go out to an external AI provider. Or there are options where you can talk about bringing the AI in-house or providing a separate container that is never re-ingested into one of the big open AI providers. So there are definitely ways to establish good enterprise practice around this, and we would always encourage that.
James, can I jump in here?
Please.
I think there's also a space for ongoing conversations with the IT department about policy. In my experience, policy is usually driven by the learnings from mistakes, which means it's conservative by nature. And I think when we're talking about leading edge technology, like what we're seeing now in the AI space, that past mistakes aren't going to inform us very well about what future mistakes could be. And I think we need to have a more open or even healthy debate with the IT team to make sure that we're aligned and wherever that alignment is.
It's a it's a point well made, Scott. I'm glad you brought that up because I wanted to address that in the sense that as we're making progress, as people are learning what is available, like that dialogue is a necessity with all the stakeholders, in an organization. First, as you're choosing how to apply this to Andrea's point of efficiency, or what projects make sense to apply these types of solutions to, and then what's the best way of going about it that takes into the considerations, all of the stakeholders in the organization. So what are we doing with this data? Where do we need to source it from? And likely that will need to evolve. And those debates should happen. They should happen up front. That should be part of the design process of bringing projects like this into being.
And I think it's worth framing this as a project and as a collaboration with multiple groups within your enterprise. This is not something where you just bring in the magic technology and it fixes everything. These are relatively big implementations that take some effort to get into. They offer the advantage that you can iterate quite quickly in the AI space. You can innovate quite quickly. Uh, but if you have not done the upfront conversations to stage you for a successful IT project generally, your AI project is doomed to failure too.
And
Uh,
James, if we went back to the two examples that we're contrasting and
mhm.
looked at negative interactions between lab and IT, we could see one where the person said, I'm fearful, but I'm fear I'm missing out, could bump into rigid IT policies that would prevent her from ever exploring the space. The opposite case is also true. In the one where he said, sort of over my dead body, we could see a negative interaction with IT saying, we're the company, the enterprise, we are going this way. We're going to roll over you because we have higher authority. And if it's over your dead body, see you bye. And we want to avoid both of those negative interactions, right? This is a space where everybody can contribute, and we need to have a healthy discussion slash debate about what's best for the enterprise.
That's also up at the little bit higher level where we are talking about the interactions between different groups in the enterprise. I want to address the individual level of this. These are innovative technologies, and we work in a domain populated by smart, capable people who are curious and will go explore on their own. And now your bench scientist is busy broadcasting data out to ChatGPT because it's helping understand some analysis or get something done quickly, and they're just meeting their deadline. Are you in line with enterprise policies? Have we talked about how to use this? Probably not. This is stuff that is going to happen and is already happening. These technologies are mature enough and have been around for long enough that we know that's going on in the background. That was one of the big themes that came out of some of the recent lab manager um, leadership conference that we attended with Scott. We heard at the AI roundtable that we know that's going on in the background. The lab managers there were very aware that their folks were already out and using that technology and somewhat fearful about was it being done in any useful, well-reasoned way. If you haven't talked about it, the answer is no, it's not being done in that. um, I think that gets it, so sort of to your point, Scott, of the interactions can end up negative either way. The positive version of this is these are disruptive technologies. They are widely available right now. People are out there experimenting with them. How do we start to bring them in a way where you're starting to structure this, where you're getting some of the benefits and you're providing a right way for people to start using the cool new tech?
I think that you phrased it properly. It's like, how can we do this? And if we can start a conversation with relatively straightforward how questions, they're not so antagonistic. They don't impinge upon other people's authority. It's sort of how can we each put our knowledge and experience together so that we can make things better. And making things better might be as simple as, let's make sure that what those creative lab rats are doing is not sharing our data with our competitors. Maybe we start there.
I love the framing that this has ended up around in this discussion. We're talking about high-end technology being a people problem. It really often is. It's the resistance to change and working through that across the enterprise. It's dealing with people bringing in sort of shadow IT solutions because they're just getting their work done and finding a way to start to talk about that. It's worth pointing out that the reason people are doing this is there really is some transformative capability here. AI provides you some opportunities that are not there in traditional approaches to your data and to your software. Particularly some of this LLM quick understanding of your data that is new in the last couple of years, that doesn't require formal training in machine learning. Adam, let's talk a little bit about sort of the innovation side of this and where we're seeing people going there.
Well, I mean, there are a lot of opportunities opening up, and I think, the industry is starting to that's the hype cycle you see, right? That everybody sees the technology, and there's kind of a gold rush to figure out how we can apply it in which possible ways. Um, it, and there's some in the evolution of the technology itself is happening at such a pace that there's very much some tumult as we try things, technology advances and makes that more capable, um, and I think that can probably be very confusing to everybody that's not kind of dedicating their time to to following that the technology itself. I'm sort of curious, Scott, on your opinion of how, as we're talking about, we've had a lot of conversations over the past, year with lab managers and bench scientists, and they want to use AI, and we talk about some of these solutions and the possibilities, but I feel there's a resistance to uptake, and that we haven't necessarily for a variety of reasons. I'm wondering if you could comment on some of maybe the top reasons where you feel whether it's education or budgets or other things where there is that sort of that roadblock to getting some of these projects started.
I'll put ignorance at the top. So I think there's a real opportunity for education. I think scientists are naturally skeptical, and a lot of the hype around AI triggers our skepticism. And so it's
Rightfully
like,
so.
yeah, show me the data, show me how this works. And there aren't so many people who can effectively do the showing. And I think that's an opportunity for Yahara to sort of carve out some space there that says, we understand labs and we can show you. I think the next one is, I'm going to call it responsibility, but whose job is this? Is this the lab manager's decision? Is it the IT department's? Is it a strategic decision that should come down line management? And I think there's sort of a mutual finger pointing of not me, right? So I hear lab managers saying, yeah, as soon as my IT department makes a decision, we're in. But are they educating their IT department? Are they engaging them? Is this a conversation that's actually happening, or is this just a when it goes wrong, I'm going to blame IT because, well, as lab scientists, we love doing that anyway. Third, Adam, yes, budget, right? This is a do more with less environment. It hasn't gotten better over the last 6 months. There's a lot of belt tightening across labs of all different kinds. And I'm hearing people say, this is a great idea, and I hope next year I can invest in it. But that's the same message I got last year, right? I hope next year so it's sort of a kick the can and use the budget as an excuse. And then the fourth is, I think that people fundamentally don't yet know how to structure their data in a way that makes this work. And if they've had a bad taste, it might be because they didn't do the right things with the data up front, which means it was sort of a garbage in, garbage out experience. And so I'll name those as the top four barriers.
Do you think maybe that last one that's interesting could be partially an expectation mismatch? The promise is out there, right? And we can do really interesting things, but if you try to maybe bite off too much, you're very likely to be disappointed with what you.
I think it's also a misunderstanding of the difference between AI and ML. Like I have enough knowledge of ML to know that I need structured data and I know that I need metadata. But if I think the system is actually intelligent, then why do I have to provide it that? I'm intelligent and I can structure the data. So why can't I just tell the software to structure the data the way you need it structured? I don't think that's how it works, but I think there's an expectation of it's intelligent. I don't need to spend time on it. I'm just going to open the top and pour it in.
And now I think we're running up against sort of a perception of what gets advertised. AI is, we've reached general intelligence. It is truly intelligent. It should be able to do all this for me. Versus, I think from the technical perspective, what I would tell you is this is an amazing leap forward in technology. And fundamentally, what it does is help you transform data. Under the hood, what LLMs are is transformers. And so now you still need a lot of that machine learning discipline. We can loosen the restrictions slightly. I don't need perfectly structured data. I can take semi-structured data. That's actually a perfect entry point for the scientific community. This is a bunch of logical thinkers. We know how to work through big, hard problems in logical, repeatable ways. That's what you've been trained to do your whole career. Now you've got a support tool that can start to ingest data more in the ways you think about it, but it's still not truly intelligent.
Another way to think about this might be any of us as scientists can take a spreadsheet with 3,000 lines in it and 20 columns and analyze one vector through that space,
Hmm.
right? We've all been trained to do it. We all know how to do it. We could all do it tomorrow. It's tedious, but it's doable. But what the expectation of AI is if I have 19 different vectors through the data, I want to do those 19 vectors simultaneously. And that's the improvement that we're looking for. Right? Could I do 19 vectors myself manually? Sure, but I'd still be doing it a year from now. And I
It
think
will
that's what we want. We want those multiple vectors, and we want also the software to be able to identify patterns that could be vectors 20, 21, 27, 50, right? That we couldn't perceive from our human senses.
And now you're into the place where AI really is, particularly the more Gen AI, the higher dimensionality view of your data, helping start to discover those patterns that you think are there, but they're kind of hidden. You can't really see them. There is power. This technology starts to unlock access to that. Again, though, in order to do it, you're going to have to have structured some of your data up front. So there is still work to do to make this go. It's not magic. It's just good at high dimensionality thinking, which interestingly is a place where humans are not great. This is the complementary aspect. What you want is the human providing the intelligence and the artificial intelligence providing the muscle.
Or the parallel,
Yes.
right? As a human, I can do it one step at a time, but I want the new technology to go through all those vectors simultaneously in parallel in a
Yes.
way that there's no way that I can do that.
And I think that's a really, really huge step forward in terms of how are we going to really see AI come into this space, is that kind of thinking, that higher dimensionality, the ability to work more in parallel, see more of the data at once. Um, there's an interesting corollary here. We know the data prep is important. We've spent a lot of time talking about it. If you've attended our webinars before, it's a common theme you'll hear Adam and I repeat. So we do the AI roundtable at the Lab Manager Leadership Summit, and Holden asks a great question, right? He's heard us talk about that. He sticks his neck out and says, "Okay, who's started doing their data prep? Whose data is ready for this?"
Were there
Dead
any
silence.
hands in the air?
None. Not one.
I'm not surprised. I'm disappointed, but I'm not surprised.
It's hard.
Is it hard or is it I don't know how to do it?
It's probably a little of both. Go ahead.
Well, no, I mean, I think we're hearing a lot of I don't know how to do it. Andrea, followed up here in chat with sort of a follow-on, she's looking to understand AI and where are all the resources to that. And I think what I'm feeling is they're either very technical or very broad. And I think we're at this place where, in the middle, right, where I'm actually doing, good innovative work on, problems that aren't just, writing email for me. That there is a gap. And that gap does require rigor, right? It requires some process and it requires time to understand a problem, understand the data that's needed to solve the problem and get it together in a functional pipeline to make that happen. And I think that's probably the gap that we're seeing out there is not a lot of good resources or not a lot of people that are able to sort of take, those business needs and the technical understanding of how this all fits together
I think
and get it into the hands of people that are using it.
one challenge for the lab is that often the raw data and the metadata are stored in two different places. Now I have it all, but I don't really know how to put them together in order to create this structured data that the two of you talk about.
Uh, Let's return to a theme that we hit a little bit when we were preparing for this. One of the one of the things that I have taken to saying is that data science is science.
And I've heard you say that before, James, and I like it.
It's it is important to start to have a data scientist approach to how you're going to manage your data. How are you going to structure it so that you can do advanced analytics on it? And I think people have started to understand that part. We know the data is valuable. We know there's more there. And it is still kind of disparate and it's not stored in one place. I'm going to start turning this on its head a little bit. Science is data science. The thinking here is a lot of the advances require some of that higher dimensional thinking that you're talking about, your 19 vectors through your data. It's hard for the human to chunk through that. Not impossible. You can do it by hand, but it just takes too long. Um, it is important to start to approach your science as fundamentally a data science problem. And that I think is one of the transformations that we would love to start to see in the laboratory community overall is you need leverage over your data in order to make not even just your operational efficiencies, but your next scientific advance, the next assay, designing things quicker, getting your analysis done in these higher dimensional spaces. We're going to have to start to change how we approach some of these problems. I think it's why there is so much interest in the technology is that's a feeling that a lot of folks have. I need this. But then to Adam's point, it's broad and the tools are not well defined, and it's hard to say, how do I, quote, get AI into my laboratory?
Well, we're also going through a lab data transformation. Over the course of my career, I have seen, well, and I'm old and been around a long time, but I've seen the transition from it's hard to make data, right? It takes me a week to make data that makes any sense that I can then ponder for a while. Now we're in a world where like these LCMS machines can make a gigabyte of data in a run. And making data is not the difficult part. It's you make so much data that in order to find the trends or the species that you're looking for, it can be a needle in a haystack problem.
And it's one of the early places you are seeing some definitive use. Here's how you get a tool that helps you analyze that data stream, in part because we know that if you are doing an LCMS type experiment, you need a vast library and better pattern recognition and more support underneath it. So if you go out to the LCMS vendors, they will have a definitive AI tool that will help you with some of that pattern recognition.
Yeah, exactly. And so that space is big enough, powerful enough, even maybe rich enough to have third-party vendors who are directly contributing. But there's lots of other data streams that benefit from these new tools. And how do we get them into the hands of the average scientist, not just the one doing genomics?
Absolutely. So, Adam, I think I'd like to pivot there a little bit and start talking about, it is broad. Are there definitive approaches where you can start to, quote, get AI into the lab? Is there a technical path or a set of tooling that we can point people to a little bit?
So I think we talk about this in a couple different ways. And I think to be able to introduce AI into your laboratory for, operational or scientific purposes or what have you, um, you need to start with some measure of strategy. So we've talked to some large companies that are starting to sort of organize, okay, what are my priorities? Where do I want to be applying AI? What are people interested in? And even those companies are coming to understand that they need to start by gathering the data. So some of these things aren't achievable short term. So the long-term strategy is to really focus on the data, focus on what you would like to do in the future, and then walk it back to what's the data that you need to support that. And that will be a process, right? That's probably that could be a multi-year process to formulate some of these plans. But in the interim, what can you do, right? I think there is the opportunity to leverage some of the hype, some of the abilities to take and make some of our daily lives easier. So go out and look at the tools like the LLMs, like for example, Claude Desktop, where you can pull in some data that you might have locally in the context of a project, have it look at that and get some insights into it. Start to test, start to say, if I had this information here and that information here, and I put it all together, can I use a tool like that to create some understanding of it?
So
Um,
Adam, can I interrupt you there? I
sure.
want to go back to Andrea's comment.
Hmm.
I love your suggestion of using a desktop version. But do you have any guidance for the lab folks out there to not overshare, to stay aligned with company IT policies, to not in have some cybersecurity issue? Where are the
Yeah.
guardrails that we can safely play with this tool?
So there are First of all, that conversation with IT is important. And if an organization doesn't have, at this point, some usage guidelines on AI and that tooling, then that you should absolutely start there. And that's a dialogue that needs to happen to understand what can or can't be shared. And, for like the big players, the Google, Microsoft, Anthropic, they've all listened. They have enterprise plans that have protections for data, assurances in those licensing agreements. So understanding within the organization what is permissible and what isn't. And some organizations will be fine with those constraints, and others will have more restrictive policies. And for those cases, you do a little bit more work, right? But you can run some of these tools, internally. And this is at a very high level, right? And I think probably, and the reason, we're talking about LLMs is those types that's off the shelf. I can pull that down. Everybody knows how to do it and start, leveraging that. It's just, you're talking to the thing. For some of the more scientific endeavors, or, creating some, true machine learning models that you're developing or applying to your data, you're going to have to do a little bit more work. But there are plenty of open source projects out there that let you do things like Olama to run local LLMs, Keras, TensorFlow, and lots of products developed on top of those libraries to be able to do machine learning algorithms locally. But that's definitely a case where you're either going to have some familiarity with the details, or partner up with someone internally or externally who does, to help you start to initiate some of these experiments, so that you can develop the intuition about do I have enough data, do I have the right data to answer specific questions that I find interesting.
I'll offer a slightly different direction, which is to say, one of the other themes we've really heard in this space is not that I need help with my scientific data, but that I need help optimizing my throughput and my workflow and my operations, scheduling, resource constraints, understanding how to tune my operational efficiencies. And that's a relatively frequent problem that a number of laboratories face. That's much less likely to be proprietary information that you need to protect because it contains a significant bit of business intelligence or something like that. This is much more just, I need help optimizing. That's a really interesting place to get started on a lot of this stuff. And now what we're talking about is, do you have good documentation around how long things take? What the loading capacity of your instrument is, or how many samples a given technician can push through a particular workflow in some given period of time. Those kinds of data you can just start gathering and attacking a an operational problem without necessarily going down the road of, I am going to expose my sensitive data to an external AI. Am I doing that the right way? There's a lot less concern around that data. Maybe your first project is a process project and not a scientific data project.
I can tell you in my years as a lab manager, I was dumping data out of the LIMS in the fashion that the LIMS allowed me to into spreadsheets, which then I massively manipulated with lookup tables and pivot tables, blah, 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 to get
Yes.
to where I wanted to go. And it would have been fantastic to dump that data into some sort of AI tool so I could simply get what I wanted to know. And Andrea put another comment in, which is right along this area of, if a lab manager out there has a LIMS, can they use an AI tool to help them make decisions from it?
We are not seeing a lot of directly integrated into the limbs AIs at this point. I am seeing some early you can chat with your data sort of very minimal interfaces. The idea is there. But if you have an off-the-shelf LIMS and it doesn't already have that integrated, can you still do it? The answer is yes. With a little bit of work. There are ways that you can expose your database so that the AI can start to introspect it and get at some of the questions that Scott's asking or maybe Andrea is asking. There are ways that you can typically export that data out into, if it's a million row CSV, so be it, right? It's, don't think I haven't done it.
Well, it feels to me like the data that's in the LIMS database, before it's exported, is pretty structured,
It is.
right? My complaint with the typical LIMS products is that somebody who was never a lab manager designed what the output reports look like, and they never serve my purposes. And so I have to dump 5 of them and then combine them myself in order to get what I want. But if I can export the data, do I assume that it stays structured, or do I have to actively do something to make it sufficiently structured for AI?
think
Typically,
that
it's
depends
going to
on,
go ahead.
well, I mean, it depends on your problem and what you're trying to achieve. I hate to use the it depends
Well,
answer,
even
but this is where we spend a lot of our time working with companies. Like we have this problem, we have this data, we need to pull that out, and oftentimes you can't just dump that out, right? Or it's not sufficient just to pull that out. There's work that still needs to be done to turn that into something usable for analytics or AI. Um,
actually, I'm pretty happy with that answer, Adam, because it's not no. And so maybe I can do it myself, or maybe I need to talk to somebody like you or James in order to help me do it. But either way, there's a path forward.
Absolutely.
There is a path forward, and I want to address sort of one more aspect of what you said, Scott, which is the reports never do what I need them to do, but they don't do what anybody else needs them to do
I
either.
don't think so.
I think the vendors would have given you the report if everybody wanted the same information. The problem here is that the number of different views of what that data means and what would be useful and informative to you differs so widely across the user base for a given LIMS system that the vendor has never found one compact way to do it, and they give you some stupid generic report that you never use. It's just so they can, it's a sales feature. Look, it does reports.
I think you're right that every lab is sufficiently different that I can't blame the vendor. I can only blame the tool, the class of tools, because they all share the same problem.
They all share the same problem. I think this is another of these big opportunities is to start to put some easier to access analytics where you are more directly able to express what you want and get the information back. That's a pretty early use case for where could the AI be making a big impact in existing laboratories without overhauling your whole ecosystem.
And for the people who are listening today, if they have this problem that I've experienced and they want to get more out of their LIMS data, is it just as easy to reach out to you guys and say, let's have a conversation? Is that a fair first step?
That's a great first step. We're always happy to have that conversation. And if you already have the data in a structured system like a LIMS and you know it's there and you just can't get to it, that's a pretty easy starting place. If you've got no data and you're unsure how to start a project, we can maybe help with some of the early stand up, but there's a lot more legwork to do to get to a place where we've got a tool that's going to help you.
Now, let me expand on that answer. You said, yeah, call us for a LIMS, but what if I've got a chromatography data system? Again, it's pretty structured data, right? It's a CDS, but it's complicated as hell. It does 10,000 things, and I only want it to do one. Can I call you and get help with that kind of system?
Absolutely. And the more structured the data is to begin with, we don't need to perfectly understand it as long as you know where the starting point is. And even if you don't understand the data structure that's under there, you know the data should be structured. You know it lives in that database. That's a good enough starting place.
Yeah, and
We
often I can dump the data, but I can only dump the raw data. I can't easily dump the metadata.
and now, these are bigger conversations and it starts to get detailed and everybody's got a slightly different problem. But
But as a
yes.
scientist who works with this data, I understand its structure,
Hmm.
whatever its structure is, because I'm using it today to solve problems.
Yes.
So if I can accelerate that through a conversation with you, that seems like a good idea. Also, I expect that if I bring to you a unstructured mess, that you'll tell me it's an unstructured mess.
And offer to help you clean it up, but it's a bigger, longer project,
Yeah.
right? It's no longer a let's start doing the cool AI. It's a let's stop and lay some foundation. And that's not a fun conversation to have. That's not where anybody wants to be. But if it's where you are and that's how you're going to get value out of your data, that might be something you need to hear. It's just not an easy conversation to have.
Or it might be that the lab has a variety of different data streams and they need to prioritize about where the biggest value of going faster or going more parallel is. And it's start there where you're going to have the best return on the investment.
Pick a high value specific project that's nicely time boxed. If we could do this, we would get a clear return out of it. That's a great project. We love that conversation.
And I think most labs are going to have a wide variety of stuff. Like in the lab that I ran, we were still running 40-year-old instruments that weren't really computer controlled,
Hmm.
all the way to something very modern, running a very new CDS and everything in between, which means we're going to have a lot of diversity of data structure.
I think that's a real laboratory, is what that's called.
Yeah.
That's what most of them actually look like. And if you've got a little bit of data that comes off the end of the instrument and that's all the more you ever get, that's fine. And if you have a fully modern, interfaceable, networkable system that's got cloud analysis software, that's fine. This is we need to meet the laboratory where they are and then work through where's that high value problem. Where's a return on investment where you could say, yes, this is definitively a worthwhile project.
And most labs are also going to have one or more key stakeholders who are, I need it perfect, I need it yesterday, and I need you to go faster. And that might be the right place to start with wherever that squeaky wheel is.
Hmm. And it's a great place, particularly if you've got somebody who is detail oriented like that. AI projects tend to be very iterative. So we'll get in and we'll do something and it won't be perfect the first time. That's okay. That's an expectation setting problem up front to say, hey, we're going to do it fast and it's not going to be quite right. Now, how do we iterate on that and improve the quality of the data or improve the speed or improve the number of variables I can look at or stage the data better? And the tighter the iteration cycle, the more progress you can see, but you start with a very short term, how do we get something done, and then scale it up to how do we really solve the problem?
Sounds remarkably like the scientific method, which
Mhm.
all us lab folks are pretty familiar with.
It is, and we don't apply the same thinking to IT projects. Please do. This is the data science is science part of the argument. This is part of the scientific process of scaling this up. If you were to hand that same problem to a technician, they would go and they would do something initial and it wouldn't quite be good enough, and then they would work through it, but more slowly because they're human. We are providing the same kinds of tooling and the same methods, we're just doing it a little faster. We've got leverage because of the tool set,
Mhm.
but it's the same kind of thinking.
I think that should give lab folks comfort, right? That they're attuned to the scientific method. It's the way that we think. And if we can apply the way we currently think simply to a new tool, then that should bring more comfort and help address the fear that's out there
Mhm.
right now.
Absolutely. We are nearing the end of our time. To the audience in general, thank you so much for joining us. And if you've got any further questions, now's the time to get them in. We'll take any last ones you've got. Adam, some closing thoughts about this discussion?
Well, this has been a great discussion, Scott. Thanks for jumping on and talking through this with us. The ideas here about data science is science and science is data science, and the process of building these models. There are things, the details of this that we haven't talked about, and that because at a high level, we're using the tools that are being created, but it's exactly how the models that are being used today, widely have been developed through this iterative process of taking data and applying different methodologies to come up with something that converses like a human would. Um, you know, don't be scared of these unknown processes, these unknown techniques, because I guarantee you, once you get under the covers, it's a methodical process for getting there, and and the understanding of that is something that I think everyone is capable of in depth.
And before I was going to give Scott the last word to wrap up, but Joseph has jumped in with a question, and I want to make sure we get that one addressed. He's talking about a customized limb system, and the policy is 100% technical review of the lab reports. It's all done by managerial review, right?
Yeah, so manual.
Very manual. Um, if AI is not typically interfaced with limbs, is it still possible to leverage AI to accomplish reviews using the exported PDFs, or does that defeat the concept of the structured data? I think you're going to find that a PDF is not wrong, and if that's the tool that you've got available, if you must export, you can still get a process in place to help automate some of this. But I think ideally you'd move it a little bit upstream. A PDF is a report, it's the polished document that's ready to go out. And in order to get the AI to analyze it, you're going to try and turn it back into data of some sort. We've got the data, it's further upstream, we know where it lives. And I would love to see in that particular case, is there some way that we could back up and get the AI inserted just a little earlier in the process and flag down the things that need more focused managerial attention?
And building on that, I would say that the managers are all looking for specific clues, right? It's part of their review. And we could teach the AI tool how to look for all of those things. So
Absolutely.
it's a training exercise, but what you do manually today works. So let's take all of those elements of what the human is doing to review it and just teach the software how to do those things.
Absolutely. And with that, Scott, I think I'm giving you the last word here. It has been a pleasure having you on. Give us sort of a closing remark here. What's the thought as we wind down?
Well, thank you for having me. I always learn from you guys when we interact, so I've got a couple gold nuggets that I'm taking away from me. I think that some of them is about we need to address the fear in the laboratory. And so all of us, the software guys, you guys, us lab folks, us in media who cover the lab, we need to make sure that we're continuing to focus on educating people about what it can do, about what it can't do. I think Adam's comments about guardrails are really important. So if we are fearful, then let's make sure that we set up with our IT departments, let's set up a safe a sandbox where we can play. And then we can gain confidence about how we can use the tool. And then I really enjoyed the part of the conversation about limbs. As a lab manager, it drove me crazy, right? I spent way too much time and generated way too much skill with pivot tables, completely unnecessary talent. And if we can just get more distance out of the data we've already got with less effort, everybody wins.
Pivot tables are the ultimate spreadsheet feature, and by the time you know how to use them, you should be doing something better with the database.
That's my opinion exactly. This was great. And, if you need me to come back someday, I'd be happy to do this again with you guys.
We'd love it.
Scott, we've enjoyed having you. To our audience, thank you so much for joining us. We're going to wrap up here and give you just a couple of minutes before you have to catch your next meeting. Thank you all, and we'll be back in about a month. We will announce that webinar topic as we have it sewn up. So thank you, Scott.
Yep.
Thanks for joining
Thanks.
us.
Take care.
Thank you.
Bye.